Okay, we're recording now. So for this first one, we have this function that we know is continuous from x equals -4 to x equals 3, both endpoints included. The graph consists of 2 quarter circles and 1 line segment shown here. And then we also have a different function. So our graph is f, but this other function is g, which is 2x plus the integral of f from 0 to whatever x is. Okay, the first thing they want us to do is to find g at -3. I'm going to start with, I'll go alphabetically. So in B, starting with you, what's the first thing that we need to do?
Find g -3.
Okay, so we've got this general form for, g of x that was given. G of x is equal to 2x plus the integral from 0 to x of f of t. So I'm going to use the same formula, and we're just going to substitute -3. So 2 by -3 plus the integral from 0 to -3 of f of t dt. Okay, and if we're integrating from 0 to -3, my upper bound and lower bound are actually flipped. And so before we actually solve this, the first thing I'm going to do is I'm going to flip those bounds again so that we can integrate normally. And if we do, the integral from a to b of any function is equal to the opposite sign integral from b to a of f of x dx. Yes.
Jade says she's waiting to get accepted.
Okay. Thank you. Hello, Jade. All right, so the first thing we're going to do is we're going to flip our sign here so that we can change our bounds. And this will become g at -3 is equal to -6 minus the integral from -3 to 0 of f of t dt. Okay, and in B, back to you. I need to be able to figure out what the integral from -3 to 0 of f of t is. This picture is already the graph of f. What are they actually asking for when we're integrating from -3 to 0 of f of t?
I'm not sure.
Sure, okay, I'm gonna open up to anyone. How can we find the integral from -3 to 0 of f of t? We were told that this graph consists of 2 quarter circles and 1 line segment. So if this graph is 2 quarter circles and 1 line segment, and then I've got 2 quarter circles for this part of the graph here. 1 quarter circle and another quarter circle. Since an integral is the area underneath the curve, if we're able to figure out what the area of this quarter of a circle would be, and that should be our integral. Okay, so for this quarter circle down here, what is our radius of the circle?
Four.
Okay, we've got a radius of 1, and we have 1/4 of that circle. So how much is this area here? Okay, next alphabetically. So that would be Jade. Jade, how much is this area here?
Pi/4.
Okay, perfect. So the area of the whole circle would be pi times r squared. Our radius is 1, and this is 1/4 of that. So this is pi/4. However, we are going above the curve for this because our line is underneath the axis. So this will be negative. Okay, then I've got another part of our function here. Let's change colors. Okay, same idea. This is 1/4 of a circle, so I need to find this area. And next is maxin. So maxin for our next area, how much is this in blue?
Um, 9/4 pi.
Perfect. So we have a radius of 3 this time instead of 1. So our area of the entire circle that's not shown, so that would be all of this space, would be 9 pi, and then we've got 1/4 of that is 9 pi/4. Okay, that's as far as I need to go in order to find g at -3. Since we only need that area from -3 to 0. Who's next? Got Nani next, but she wasn't here for the first part, so I'm going to skip to Sai. Sai, let's finish this off. So g at -3 should be equal to what?
So I'm not sure.
So first part's going to stay the same. This is -6, but I'm going to subtract our integral. That integral is the area underneath the curve. From x equals -3 to x equals 0. So from x equals -3 to x equals 0, how much area was there?
Hmm. Um,
Throw some labels on really quick. This is -1, -2. This is -3, and then -4. So from x equals -3 to 0, how much area was underneath the curve?
9 pi/4.
That's it. Okay, so g at -3 then should be -6 minus 9 pi/4. If we need to get a common denominator, we can. Nani, I'll jump to you for that. So I want to combine this into one fraction. This is -6 minus 9 pi/4. What should I do?
-6 minus 9 pi/4.
Okay, you're right. I need to get a common denominator so that we can combine these into one fraction. So what should the bottom be?
4.
Okay, 4. Then what would the top be for the -6?
-24
right.
minus 9 pi.
That's it. And that's as much as we can simplify, so I'm gonna leave it just like that. Okay, so that's g at -3. That was the first part. I also need to find the derivative of g in its general form, and then use that to find g prime at -3. So if that's part A, and then I've got part B here. G prime at x should be equal to, that's the end of the order, so I'm back to in B. In B, if g of x is 2x plus this integral, then what is g prime?
Mm,
I'm gonna rewrite our original up here first, just to keep things clean. So this is
uh, 2 plus.
not sure. Okay, so this is the derivative of an integral. I'm gonna give us an example really quick. And then we'll use that to make a general form. So what we're doing is this. We are deriving the integral from, I'll make this general, so from a to b of some function f of x in terms of x. Okay, so for example, if our f of x was just x to the first power, then when I integrated, I would get x squared over 2, right? I'm going to call that integral of f of x. We'll do a capital F. So working this out, this would be the derivative of whatever our integral of f of x is, that's capital F, of our upper bound, b, minus capital F of our lower bound, a. Okay, then when I go to derive this, the derivative of f of b would get me back from x squared over 2 to x again. So this would be the derivative of f of b would be my lowercase f of b. But then if b was a function, I would have chain rule. So I'd have to multiply by b prime. Okay, I'd do the same thing over here. I would get f of a times a prime. So in general, if you derive an integral, you'll end up with the exact same function, but plugging in your upper bound and with chain rule. Minus the exact same function, but plugging in your lower bound with chain rule. Okay, with that, if I wanted to derive the integral of f of t from 0 to x, what would happen?
F of x times x prime minus f of 0 times 0 prime.
0 prime, okay, and we'll simplify a little bit. Jumping to Jade. Jade, what is the derivative of x in terms of x?
1.
1, so this is f of x. And then what is the derivative of 0 in terms of x?
0.
0, so this is minus f of 0 times 0. And then anything times 0 is 0. So we can cancel out that whole term. So I could say the general form for g prime at any x value is 2 plus our y value showing on the graph. Okay, last step, I'm going to plug in -3. And we should get our answer there. So this is 2 plus the y value showing on the graph at -3. Maxine, can you finish this off? What is f at -3?
Zero.
0. Our y value at -3, so that's here, is 0. So this is g prime at -3 then is 2 plus
Equal
0
to
over
2.
2. Okay, so we found the general form of g prime, and we got g prime at 3. We should be good. Any questions on A? Okay, I'm gonna mark these really quick. Okay, these 3 parts in the boxes be your answer for A. If this was the AP exam, you would not actually need to show your work. You could also leave this first one unsimplified. You don't have to combine into one fraction. If you're asked for a free response. If it's a multiple choice though, you would need to be able to match this on the multiple choice to the simplified version. So I'm doing the simplified for practice, but on the real FRQ, you don't need to simplify. Okay, so that's all part A. Then part B. Determine the x coordinate at the point at which we have an absolute maximum on the interval from -4 to 3, and then justify your answer. Okay, so we're looking for g to have an absolute maximum, and then g is this function down here. Who's next? I've got Nani next. In general, how would I know when we have an absolute maximum? For any function.
If it's concave down.
Okay, so if I've got a point where the slope is 0 and we are concave down, then I would have a relative maximum. So that's a point that's higher than the points around it. For an absolute maximum, they're looking for the highest possible y value. So that means I do actually need to test the start point and end point since we have an interval, in addition to the points where the slope is 0, because maybe my relative maximum is not the largest y value if the start point or end point is higher. So to find an absolute maximum, we'll need to test the start point, the end point, and any relative maximums. So that's points where the slope is 0 and we are concave down, or points where the slope is 0 and our slope changes from a positive slope to a negative slope. Okay, so that's what we're going to do here. And the first thing I'm going to do is I'm going to figure out if there's any points where g prime is equal to 0. Okay, so here's our formula for g first. G of x was given as 2x plus the integral from 0 to x of f of t in terms of t. And we do actually have a general form for the derivative already solved from the previous problem, so I'm just going to copy that. G prime at x is equal to 2 plus f of x. And if this is equal to 0, then we'll have a critical point. So it's a point that could be a relative minimum or maximum. Okay, Nani, back to you. So I've got 0 is equal to 2 plus f of x. So how would I know when g prime is supposed to be equal to 0?
Um, when two,
Not 2,
-2.
-2. There we go. So when the y value is -2, g prime is 0. Okay, so I'm going to zoom back out and we'll take a look at the graph, and we need to find a point where the y value is equal to -2. Who's next? Got Sai. So Sai, I need to figure out where the y value is equal to -2. So here's a green line through y equals -2. I need to figure out this point. How can I find this point?
To substitute -2 into the equation.
Unfortunately, we don't have an equation for this. So we can do that. We'll just need to create an equation. What would the equation of this line be?
Is the highest point on x equals to 0 is 3?
Yes.
So um
Okay, I've got options. You can either use slope-intercept form or you could use point-slope form. Which one do you think you would prefer for this one?
second one.
Okay, if I'm going to use the second one, then I need 1 point and 1 slope. So I've got a point here at 3, -3. What's the slope of the line?
-1/2.
Okay, so it's down 6 and over 3. So rise over run, that would be -2/1.
Okay.
Okay, so this would be y minus -3 equals -2 times x minus 3. And I could leave it like that. Okay, so that's our equation of a line. And then when our y value is equal to -2, then g prime x is 0. The other way we could do that is if you wanted to use slope-intercept form. Again, our slope is rise over run. So I went down 6 and over 3. So this would be -6/3 is -2 for m. Y is -2x plus 3. And I'll end up with the same thing. Okay, so I'm going to stick to size y plus 3 equals -2x minus 3. My y is my f of x. Okay, when f of x is -2, I need to know what the x value is. So I'm going to substitute. -2 plus 3 is equal to -2x plus 6. So I've got x is 5/2. Is the point where our slope is 0. Okay, I'm jumping to NB. In B, we've proven that we have a critical point where the slope is 0 at 5/2. How do I know whether this is a maximum point or a minimum point?
Um, check if the equation like, starts with positive or negative.
Okay, so I've got two options. So for a maximum point, if our slope changes from positive to negative, then that would be a relative maximum. Or if we're concave down, then this would also be a relative maximum. So I can either check slope or concavity. For this one, I actually think it would be easier to do a second derivative test and check our concavity around that one point. But we can do this either way. The reason why I think it would be easier is because we already have this equation for g prime. So if I derive this again, then I'll just be left with f prime, and that's one number that I can check. I'm going to do this the faster way first, and then I'll see if I can do it the other way using a first derivative test. So at the point x equals 5/2, we said g prime is 0. This is what we've already proven. G prime prime at x, to get a general form, would be my derivative of this equation. And be back to you. What's the derivative of 2 plus f of x?
Negative 2 over x plus f prime x.
Okay, we're close. What's the derivative of 2?
0.
0. Okay, so I've got 0 plus f prime x, you said. That's perfect. Make that prime just a little bit bigger. So our second derivative of g, which will tell us the concavity at this point, is just the first derivative of our graph. So I'm going to go back and we need to find the slope of the graph at that point, which Sai already got for us. Rise over run, we said this is -6 over +3 or -2. G prime at 5/2 is equal to the first derivative of f at 5/2, which was equal to -6/3 or -2. Okay, NB, last part. So we have a point right now where the slope is 0 and we are concave down. Is that a maximum or a minimum of g?
Maximum.
Maximum, perfect. So slope is 0 at that point and we are concave down. So this would be a maximum. Okay. On our AP exam, I wouldn't actually need to write that out, but I could say something like, as g prime at 5/2 is 0 and g prime prime at 5/2 is negative. Therefore, g has a relative maximum at 5/2. Okay, so in order to prove that this is an absolute maximum, not just a relative maximum, I need to prove that this is the highest y value possible for G on the entire graph. And that means, since this is the only relative maximum that we have, I need to test this point, but then also the start point and end point of the intervals to see if we started at a higher y value. So I'm going to make a table really quick. This table is going to have all x values where g of x could have the largest y value. So that means our starting x value on our interval, which was from -4 to 3. So starting was at -4, ending point was at -3, and then we have our critical point in the middle at 5/2. Okay, so far we've proven our graph looks something like this. We have a relative maximum at 5/2. However, we were a piecewise function. So I do need to prove that we didn't actually end up coming up higher than that at the end. Okay, so I'm going to plug in -4, 5/2, and +3. -4 to +3 into our g of x function. Okay, we've already plugged in 5/2. Oh, I didn't actually put that in the g prime, so I need to plug all these in. G of x is our original function, 2x plus the integral from 0 to x of f of t dt. Okay, so I'm gonna have 2 times whatever number this is, and then plus the integral from 0 to whatever number that is. This first one then would be g at -4 is equal to what? I've got Jade next. So Jade, what do I have to do here?
-8 plus integral 0 to x f -4.
We're closer. X value is -4, not the t value.
Sorry, then?
X
Okay.
is -4, so this should be integral from 0 to what?
Zero to 3.
Okay, I've got x, x, x. So all of these are going to be replaced. This was 2 times -4. So I got the -8. So that means this one should also be changed. This will be
Also -4.
right. So I'm going to integrate from 0 to -4. The rest of this will stay the same, of f of t dt. Okay, so I want the area underneath the curve from 0 to -4, but my upper bound and lower bound are swapped for this one. I'm going from really an upper bound to a lower bound. How can I change this to go from left to right?
Flip it.
Okay, I want to flip it. Every time that I flip my integral, my sign will change. So this will become -8.
Plus, no, minus. Integral 4 -4 to 0. En 1 over ft. Of een ft natuurlijk, sorry. Welk dat?
Sorry, FT, we haven't quite integrated yet. We don't actually have a formula for this. So in order to integrate, I'm going to have to go back to the graph and we'll take a look at our areas. Okay, so in the first part of this, we already got areas. So I've got negative pi fourths and 9 pi fourths are my areas for the yellow and the blue part from -4 to 0. So I can substitute directly in for that. So Maxon, what will g at -4 be then? Well, let's zoom back out so we can see the graph.
Um, 2 pi in the parentheses.
Right. So this would be 9 pi fourths minus pi fourths is 8 pi fourths or 2 pi. And so g at -4 is -8 minus 2 pi. Okay, I'm gonna do the exact same thing for 5 halves and 3. Okay, Maxon, I'm going to stick to you for this. So g at 5 halves is going to be this equation. So I've got g at 5 halves being 5 plus our integral here that I'll need to substitute for. So I need the area underneath the curve from 0 to 5 over 2. Okay, I'm going to break this up into 2 areas just like we did last time. So here I've got an area in pink that would be positive. What's the area of this pink region?
(4.5 over 2).
Okay, so this is 1/2 base times height. So I've got 3 and then 1.5, or 3 over 2. So this is 9 over 2 divided by 2 is 9/4. I'll write that out really quick. So this is 1/2 of our base times our height. Okay, then I've also got another triangle here in green. What would my formula for the area of this triangle be?
1.
Okay, so I've got a side length of 1 here. How much is this side?
2? Is it 2? Wait.
2. Okay, so my area is 1. We're above the curve.
Oh, right. So it's -1.
Right. Okay, so that was 1/2 of 1 times -2 is -1. Okay. So I needed the integral from 0 to 5/2. So I just need to add those together. I've got 9/4 minus 1 is how much?
Is it still me?
Yes, sorry.
Um, 5/4.
5/4. Okay, so that's our answer for this part. Five plus 5/4. Okay, so we've got 5 plus 5/4. I can get a common denominator, and that's it for this part. So this is g at 5/2 is equal to 25/4. Okay, last one. I'm going to do the exact same thing, but plug in 3. Okay, so next up is Nani. G at 3 would be 2/3 plus the integral from 0 to 3 of f of t dt. Or 6 plus our area underneath the curve from 0 to 3 of our graph. Okay. Nani, I'm going to take this triangle and we're going to change it. And I'm going to extend this area to here. What's the area of our new triangle in green?
-3.
Okay, I've got -3 for the first side length. What's the top side length?
2.
So I've actually got 1.5 for the top.
Let's see. So the area is -9/4.
Perfect. So that does make these symmetric. And if I wanted to multiply that out, that would be 3/2 times -3 times 1/2 because it is triangle. Gives me -9/4. Okay, so I'm going to substitute that in for our integral. Okay, I'm getting a common denominator. This is 24. Or 15/4. Okay, so what I have here is our x value of everything that could be the largest y value. That's my start point. Our maximum and our endpoint. Just write relative maximum maybe. Which one ended up being the largest possible y value? Nani, what's our biggest g of x?
The maximum.
Okay, at the relative maximum was the largest y value. So that means our absolute maximum is at x equals 5/2. Okay. For this particular problem, I probably didn't need to actually test my start point and end points because we can prove that all points before 5/2 are going to end up giving us negative values, and all points after are going to I can prove that we're going to change from a positive slope to a negative slope for all points before this. So I could have just ended there. But I did want to go through this process because it's going to help us later on.
Question.
Go for it.
So do we have to do all of this to justify our answer?
So for this problem, I'll flash the scoring guide really quick, but wow. There we go. Okay, this is all you would need to get full credit. So this first part is proving that our derivative was 0 at that point, which is at x equals 5/2. Because our slope is positive before 5/2 and negative afterwards, I can prove that we're changing from positive to negative slope. It gives us a maximum. So they had checked the slope for all points before and after this. There were no other critical points. The slope couldn't change from positive to negative. I wanted to do a little bit more than that because if I had a function that looked like this, where I kept going up after a relative maximum, or had been going down from a start point before that relative maximum, it would be possible for a start point and an end point to have a higher y value than this largest relative maximum.
Okay.
In order to prove that we have an absolute maximum, so that's what is the highest y value from point A to point B, from a start point to an end point. And you'll need to check for all of your relative maximums and test the y values against the start point and end point to prove it for sure. Okay, the reason why we didn't need to do that for this one is because we only had one critical point. So that means I had to go up from the start point and I had to go down to get to the end point. So this had to be the absolute maximum. So they've skipped all of this part because we only had one critical point, which is fine for this problem, but I wanted to show it anyways because you're going to end up with other questions later on in the year that will need you to do more. Okay, that's part A. Part B. Find all values of x from -4 to 3, where the graph of g has a point of inflection, and give a reason for the answer. Okay, g will have a point of inflection whenever the second derivative of g is equal to 0 and changes sign. So I'm going to go below this, I guess. Okay, finding the point of inflection of g would be whenever g prime prime of x is equal to 0. We said earlier g prime prime of x would be equal to here g prime prime of here actually g prime prime of x is 0 plus f prime x. So g prime prime x is f prime x. Okay, so if f prime x is 0, then g prime prime x is 0. So I'm going to look at the graph. We need to find the points where the slope of our original graph is equal to 0. I forget who I'm on. I think I'm on Psi next. So first taking a look at this graph. Psi, are there any points where the slope of this graph is equal to 0?
No.
No, okay. Are there any points where the slope would be undefined?
No.
So I've actually got 2 points where the slope is undefined. So that's when
Oh.
the different, oh, go for it.
Is it x equals to 0?
X is 0 is one of them. What's the other one?
X equals to -3?
Perfect. X equals 0 and -3, we don't have a slope defined because we're changing functions at that point. So my slope doesn't neatly match from the left and the right. In order to have a derivative, my limit from the left and the right of the slope has to approach the same value. Okay. So I can have a point of inflection anytime that we're changing sign. Is there any point where the slope changes from positive to negative or from negative to positive? Sai, sticking with you.
Sorry.
Is there any point in the graph where the slope changes from positive to negative or from negative to positive?
At x equals to 0.
Okay, only at x equals 0. So x equals 0 is our only point of inflection, the only point where our concavity of G, which is the slope of f, is changing. Okay. F prime x. Okay, it's really an undefined point. F prime x. All right, changes sign. That's better. Changes sign at x equals 0. So G has a point of inflection. At x equals 0. Okay. So one more time to the top for that one. Earlier we said the equation for G prime prime of x would just be f prime x. So if the concavity of G is the slope of f, and f changes slope from positive to negative at 0, then the concavity of G changes from positive to negative at 0. A point of inflection is anytime your concavity changes sign. So G has a point of inflection at x equals 0. Last one. I want to find the average rate of change of f from -4 to 3. There is no point where f prime is equal to that slope, and I want to explain why that doesn't contradict the mean value theorem. Okay, I'm going to start with NB. I need to find the average rate of change from -4 to 3 of f. Okay, how would I find the average rate of change from x equals -4 to x equals -3?
Find the slope.
Perfect. Average rate of change is a slope. So what they're really looking for is to find the slope between these two purple dots. Okay, so we went from -4, -1 to 3, -3. How do I find the slope?
Um,
Okay, copy those points down here really quick. Okay, NB, back to you. What should I write here?
-3 minus -1 over 3 minus -4.
Awesome. Okay, so this is -3 plus 1 is -2 over 3 minus -4 is 7. So I've got an average slope of -2 over 7. Okay, so that's the first part of this. The second part of this, they want to know, why does the mean value theorem not apply? I'm going to open this up to anyone. From 2 or 3 weeks ago, the mean value theorem tells us that as long as our function is continuous and differentiable, then our average slope should be equal to the derivative of our graph at some point between A and B. So in our case, from the start point A to the end point B, our average slope was -2 over 7. But there is no point on this graph where the exact slope, the derivative, is -2 over 7. How is that possible? So why does that not contradict the mean value theorem?
Because our function is not continuous.
We're really close. The function is continuous.
Or not able to derive.
That's it. We're not differentiable. At what 2 points are we not differentiable?
-3
Is it the
and
2 points where? Right.
Yes and yes. It is 2 points when we're meeting different functions, and that's at -3 and 0. So because we're not differentiable, the mean value theorem does not apply. Okay. Says okay. I've done a lot more work than what would actually be required on the AP exam, so I'm going to take a step back I'll look at their scoring guides and I'll explain how you would be scored on this. And then I'll score our work as we go. Okay, so this is their scoring guides for this. Our first question, find g at -3, g prime at x in general, and then evaluate it. So I've got 1 point each for those. G at -3 would be what happened if I plugged in -3 into the general form that they gave us here. If I do, when I go to find the integral from 0 to -3 of f of t, I do have to subtract change our bounds in order to solve that, but it becomes -9 pi fourths because our radius here is 3, meaning this entire quarter circle here has an area underneath it of 9 pi fourths. So this is -6 minus 9 pi fourths, and we get full credit for that. Okay, so we had put some black, I guess. Okay, -6 minus 9 pi fourths is g at -3, so that's 0.1. 0.2, g prime would be the derivative of what they gave us. So the derivative of 2x is 2. The derivative of an integral would be f of b, so that's f of our upper bound times b prime minus f of a prime, f of our lower bound times lower bound prime. So that's 2 is the derivative of 2x plus f of our upper bound, f of x times the derivative of our upper bound is 1, minus f of 0, the derivative of our lower bound is 0. So that's 2 plus f of x. 2 plus f of x. Then g prime at 3 is what happens if I plug in -3 into our equation that we just got. So that's 2 plus f at -3. F at -3 is 0, so that's 2. Okay, so that's 3 points out of 3. We get full credit for A. Okay, for part B. In order to find out when we're going to have an absolute maximum, I need to check all of the critical points. That's points where the slope is equal to 0. And then we also need to prove that they're maximums, so that we changed from a positive slope to a negative slope, or that we were concave down. So this first point says we've checked that g prime is equal to 0 and found that point. So as long as you checked for g prime at 0, we get the first point, which we did. We set g prime equal to 0 right here. Okay, then after that, identified an interior candidate. So we found out it was 0 at x equals 5/2, which we did here. And then justified that that was the absolute maximum. So we can justify that's the absolute maximum by doing what we did, checking the critical point, the start point, and end point to see which has the largest y value. This will work for any function. So this would count as justification. However, for our specific function, we only had 1 point where the slope is equal to 0. So if I was to prove that before 5/2, our slope was positive, and after our slope was negative by checking 1 point that we plug in into g prime, then I can prove that this is the highest point on the interval, because our start point would have to be lower and our end point would have to be lower. So they've shortcut for that part here, saying that our slope would have to be below 0. Or sorry, our slope would have to be greater than 0 from -4 to the point, and below 0 afterwards. Our slope can only change from positive to negative at a critical point. Okay, for part C, we're finding all points where G has a point of inflection. Our graph will have a point of inflection for G whenever G prime prime is 0 or changes sign. G prime prime is F prime, and F prime only changes sign at x equals 0. So that's our point of inflection. Okay. G prime prime will be 0 at a point of inflection. G prime prime is f prime, and f prime changes sign at x is 0. Last one. They asked for the average rate of change. Average rate of change is our algebra version of slope from the 2 points that they gave us. So from -4 to 3, our average slope would be y2 minus y1 over x2 minus x1, or -2/7. 1 point for getting average rate of change. The mean value theorem does not apply because we're not differentiable on the interval. At x equals -3 and 0, we're not differentiable. Okay, average rate of change is -2/7, and we are not differentiable. All FRQs, all FRQs are going to have a total of 9 points. It is still possible to be in pass range if you're scoring like 3 or 4 points out of 9. How much leeway you have kind of depends on the multiple choice, but I would expect someone that was scoring an average of 3 points out of 9 to still be able to pass the AP exam. So these FRQs are designed to be a little bit hard. This is the first one we've done. We're going to have a lot more practice on this through all of next year. But eventually we'll get to the point, hopefully by November-ish, when we'll be doing these as time tests. On the actual AP exam, we'll need you to be averaging 15 minutes per FRQ. Your exam is split up into a multiple choice and a free response question set. Your multiple choice set is split up into a no calculator and with calculator multiple choice section. And your FRQs are also split up into with calculator and without calculator sections. You have 2 questions that are with calculator and 4 questions that are no calculator for your FRQs. Any questions on what we did?
No.
All right. I actually don't have physics tonight because they asked us to reschedule. So I've got time if anyone wants to stick around to go through the second FRQ. If you don't have time to stick around, that's okay. And you guys can feel free to leave at any point. But if you want to stick around, I'll go ahead and finish this one off. I'm going to repaste this down a little bit so that we can have some extra space though. Okay, so I've got a differentiable function, which has all positive real numbers that are okay to plug into it, and for which the derivative is given here. Okay, the first thing they want us to do is find the x-coordinate of the critical points of f, and determine whether that point is a relative minimum, maximum, or neither, and justify our answer. I believe I finished with NB, so I'm going to start with Jade. Jade, it's huge. How do I find the critical point of f?
Derive is equal to 0.
Perfect. So we already have the derivative here. So I'm going to set this derivative equal to 0 and we'll solve for x. So given f prime x is 4 minus x times x to the -3rd power, or 1 over x cubed. 0 should be equal to 4 minus x over x cubed. Jade, I need to solve for when x would be, when f prime would be 0.
When x is 4.
Perfect. So I'm going to multiply both sides by x cubed. That gives us 0 is equal to 4 minus x, or x is equal to 4. Okay, so that's our critical point. I can also have a critical point of our functions undefined. Is there any x value for which our f prime would be undefined?
0.
At 0, perfect. So I can say f prime x is undefined, so that does not exist at x equals 0. Oh, okay. Actually, I don't need to do that because our domain's different. Sorry. We have to be greater than 0 to be on our function. So I don't need to test that point. Okay, so our only critical point then is x equals 4. I need to determine whether this is a relative minimum, maximum, or neither, and then justify our answer. I'm going to jump to maxim. How do I know whether this critical point is a relative minimum, maximum, or neither?
By testing its concavity.
Okay. So I've got two options. The first one, you're right, we can test the concavity. Second one, we could do a first derivative test. That means test to see whether the slope is positive or negative before and after that point. I believe a first derivative test would be faster in this case, only because that means we won't have to rederive this. And it looks like it'll be easy to plug in points right now. I'm going to do a first derivative test for this one, but you're right. If I derived this again and then plugged in x equals 4, that would work too. I'll end up doing both, I guess. So first derivative test. I'm going to draw a number line and then list all my critical points here. I have only a critical point at x equals 4 since our line has to stop at 0. Plugging into f prime x, one value that is less than 4 and one value that is greater than 4 should tell us whether this is a relative maximum or minimum, because that'll tell us whether the slope changes from positive to negative, which would be a maximum, or negative to positive, which would be a minimum. Okay, Maxim, back to you. Pick any number you want between 0 and 4, and then plug that into our equation to see whether our slope is positive or negative at that point.
Could we do 0?
I can't do 0 because our function only exists when we're greater than 0.
Yeah. 1.
Okay. So we want to find f prime at 1, which would be our functions here. So what happens when I plug in 1?
3.
Perfect. I'm going to write this out, but you're right. So this is 4 minus 1 over 1 cubed, or f prime at 1 is 3. Okay, so that was positive. So our slope was positive before 4. And then I'm going to plug in any number you want that is above 4, and we'll test that as well. So pick one more point above x equals 4.
Okay. 5.
Perfect. So this is 4 minus 5 over 5 cubed. Will our answer be positive or negative?
Negative.
Negative, you're right. Now we don't actually have to solve this since all I need to know is the sign, but this is negative 1 over 125, which is negative. Okay, my slope changed from positive to negative. So is this a relative minimum or maximum at x equals 4?
Wait, so it changed from positive to negative?
F prime changed from positive to negative. So this is the slope of f changes from positive slope to negative slope. So at x equals 4, is that going to be a relative maximum, relative minimum, or neither?
Neither?
So in this case, this will actually be a relative maximum. We changed from a positive slope, so that's going up, to a negative slope, going down. So this should be a maximum.
Okay.
Okay, so that's the first way we can do this. I believe that's the fastest way for part A. You said you wanted to test concavity, and that would also justify our answer. So I'm going to do that as well. But on your AP exam, you'd only need one of these. Okay, so the other way we could justify is using what's called a second derivative test. Second. Okay, pen's dragging a little bit again, but second derivative test. Okay, I'm going to jump to next is Nani. F prime x was 4 minus x times x to the negative third power. I'm going to simplify f prime first, and then we'll derive it. So Nani, can you distribute?
Yes. 4x to the negative third power minus x to the minus x to the negative 4. Actually, negative 2.
Negative 2, okay. So if this is f prime, what happens when we derive? Okay, Nani, still with you?
Negative 3 times 4, 12x.
Okay, negative 12x to what power?
Negative 2.
Not negative 2, no. Negative 4, there we go. Negative 3 minus 1.
Minus 2, negative 2x, so positive 2x, negative 3.
Negative 3, perfect. Okay, so this is my general form for the second derivative. I want to be able to test the concavity for my second derivative test at the critical point, which is at x equals 4. So I'm going to plug in x equals 4 here, and we'll see whether we are concave up, which would be positive, or concave down would be negative. Okay, I'm going to jump over to psi. We need to know what f prime prime is when x is 4. Okay. Let's simplify this a little bit. 12 is, or negative 12 rather, is negative 3 by 4. And that will allow us to cancel out one of those 4s and get a common denominator and make this a little bit easier to see. So after canceling out one of these 4s and getting a common denominator of 4 to the third power, or 64, what's left on top?
Negative 3 plus 2, so negative 1.
Perfect. So we've got negative 1 over 64. That is negative. So we are concave up or concave down?
Concave down.
Perfect. F prime prime at 4 is less than 0. So concave down. Maybe more specific, actually. F is concave down. X equals 4. Okay. So what that means is, because x equals 4, f prime x was 0, we have a critical point where the slope is 0, point where the slope is 0, and we just proved that our function is concave down at that point. So that's enough justification that f is a relative maximum. For our first derivative test, we proved that the slope was 0 at x equals 4, and that the slope changed from increasing to decreasing at that point, which is also enough proof to say that we have a relative maximum. Okay, so 2 ways to prove it. We call them first derivative test because it only uses the first derivative, or second derivative test because we have to derive again in order to use the concavity. Which one's faster kind of depends on what information you were given and how difficult it will be to derive again. Any questions on our first derivative test or second derivative test?
No.
Awesome. Okay. Determine whether the point is a relative maximum, minimum, and either. Okay, so f has a relative maximum at x equals 4. And then my justification would either be the first derivative test or the second derivative test. F prime at for x value 4 is 0, f prime at 4 is negative. That's enough justification. Okay. Part B. Find all intervals where the graph is concave down and justify our answer. Okay, if f is concave down, what has to be true in B?
The second derivative is negative.
Perfect. So I'm looking for all points, all intervals, so all ranges where the second derivative is negative. Okay, we already have a general form for the second derivative here, so I'm going to copy this line down here. Okay. Indy, back to you. Is there any way that I can factor this out so it'll be easier to see when this changes from positive to negative?
2x to the negative third power.
Okay, 2x to the negative third power. That's good. What's left then?
Minus 6 x to the negative 1 plus 1.
Awesome. Okay, so if I set the second derivative equal to 0, that will tell us all the points where this could change. Because we're multiplying two things together, if this is equal to 0, then the whole thing's equal to 0. And if the right side's equal to 0, the whole thing is 0. So I can set up two separate equations. And then I just need to solve those equations to figure out when this is true. Okay, over to, actually, I haven't really done anything other than factor. I'm going to stick with NB for this one. NB for the left side, are there any x values that can make this true? No. Okay, so no values will make that true. On the right side, what can I do?
6.
Okay, so 6 will make this true. I'm going to go ahead and throw a step in here. So this is 6 over x equals 1. Therefore, x is 6. Okay, so at x equals 6 is the only point where our second derivative is equal to 0. Our question was asking when we're concave down. So I'm going to test points around this and we'll get an interval. Okay, I do actually have a breakpoint at 0. So we cannot test any points that are below 0. So testing into the second derivative. I want to know whether the second derivative is positive or negative before 0 and a positive or negative after 0. Since 6 is the only point where we were equal to 0 exactly, we have to touch 0 to change from positive to negative. All points from 0 to 6 will be the same sign, and all points after 6 will be the same sign. Okay, general form was this one. I'll steal from here actually. So 2 over x cubed and negative 6 over x plus 1. Jade, over to you. I want you to pick any point you want between 0 and 6, and we'll plug that in and see whether our concavity is negative or positive.
1.
Okay, 1's the easiest. So if I plug in 1, I get 2 over 1 by negative 6 plus 1. Is my answer positive or negative?
Negative.
Negative. So I've got negative, it's 10 really, but. Okay, and then I need any number you want that is above 6.
7.
Okay. So this will be 2 over 7 cubed times negative 6 over 7 plus 1. Will my answer be positive or negative?
Positive.
Positive, you're right. This side is positive, this side is positive, and positive times positive is positive. Oh, purple. Okay. The same thing over here is less than 0. So, because our interval starts at x equals 0, the only interval where we are concave down is from 0 to 6. I'll do interval notation. 0 is not included because that's the start of our interval. They gave us x has to be greater than 0. To 6 is also not included because at 6 exactly, we're not concave down or concave up. We're neither. Any questions on B? Finding the interval where f is concave down.
No.
All right, last part. Given that f of 1 is 2, find f. String, I cannot string. Okay, I'm gonna have to screenshot again. Okay, so this is part C. Okay, f of 1 is 2. I want to find f. I know that f prime is this. Okay, the first thing I'm going to do is I'm going to simplify f prime again. F prime will be, since Nani already did this earlier, I'll do this from x in first. This is 4 x to the negative third power minus x to the negative second power. Maxon, over to you. I want to determine f. Right now we have f prime. So what do I need to do?
Integrate this.
Perfect. I need to integrate. So
F of x equals to, oh,
okay, sorry, go for it.
negative 2x to the negative second power.
Okay, so I'm gonna write this out because it's been a while, but this is 4x to the negative 3 plus 1, or negative 2 over negative 2. Okay, and then the next one.
Minus x to the negative 2 minus 1 over.
Integrating, so I'm gonna add 1 to the power actually.
Oh, right. X to the negative second power plus 1 over negative 1.
Perfect. Okay, and then we're integrating indefinitely, so I need one more thing.
Plus c.
Plus c, perfect, because we don't have bounds. Okay, so my general form for f of x is what happens when I simplify this.
Negative 2x to the power of negative 2 plus x to the power of negative 1 plus c.
Okay, and I'm going to go ahead and rewrite those as fractions too, so this will be easier to plug in. Okay, so we were given 1 point. F of 1 is 2. So I can use that to solve for c, and then we'll have an actual function. When x is 1, f of x is 2. I'll write that really quick. F of 1 is 2. So therefore, 2 is equal to negative 2 over 1 squared plus 1 over 1 plus c. Okay, that was all maxed in. So Nani, over to you. I need to solve for c.
C is equal to 2 minus negative 2 over 1.
Okay, that's minus a
1 over
negative, so I'm going to add 2.
plus,
Okay,
is equals to 4. Wait, plus 1 also. Plus 1.
okay, I'm going to stick to what you were doing. So this is the 2 from the left side. And then we subtracted negative 2 over 1 squared.
And then plus 1.
I got to move it to the other side. So this will be
Negative 1.
right. I'm going to swap this equal sign over here so you can see what we did. But I subtracted the 1 to move it to the other side. I subtracted this part to move it to the other side. Okay.
So it's equal, C is equal to 3.
Right. Okay, so C is 3, and then I can go back into our general equation, plug in C equals 3, and then I'll have a particular solution. So f of x is equal to negative 2 over x squared plus 1 over x plus 3. Any questions on what we did?
No.
All right. I'm going to flash the scoring guide for this one too, just so you can see how we would get our points. And we'll check against our work too. Can I make this side by side and still let you guys see? Yeah. Okay. So for the first one, we were looking for critical points. So I've got 1 point for saying that we have a critical point at x equals 4, 1 point for saying it's relative maximum, and then 1 point for our justification. So they justified using a first derivative test, saying that our slope changed from positive to negative at this critical point. I justified with the second derivative test, what I wrote here, that our slope was 0 at x equals 4 and concave down. Either way is fine. Okay, so 1 point x equals 4. 1 point x equals 4. 1 point saying it's a relative maximum. 1 point for justification is this part. Okay, for part B, find all intervals where you're concave down and justify the answer. 2 points for the derivative, or second derivative of f. Okay, second derivative f as 2 by x minus 6 over x to the 4th power. Okay. I didn't quite break it up the same way that they did, but we do still match. And I've got the concavity interval here. So that's still fine. Second derivative. And concave down. I simplified the f prime value before we derived. They left f prime like this and then derived with chain rule. But we should still get full credit for that as long as our derivative is correct and our interval is correct as far as being concave down from 0 to 6 afterwards. I actually like what we did better than what they did. I think we're faster in this way. Then the last one for C. I've got 1 point for our integral. Antiderivative and answer. Okay, integral. Okay, we integrated directly and got. It's okay. I integrated indefinitely and then solved for C. They integrated definitely around that point. That's okay though. So we get 1 point for our integral. So we got 1 point for integrating, 1 point for the antiderivatives. That's actually the solution of your integral indefinitely. Then 1 point for your answer after the definite. So we should still get full credit for that too. And that should be good. Any questions on this one? 9
Nope.
points again. All right. So that's both 3 response questions. We did still have a bunch of multiple choice questions. I'll stick around for a little while. If anyone has multiple choice questions, I can answer those too. Again, if you guys needed to go at any point, feel free to go. So I'm going to open this up now. Anyone have any other multiple choice questions for the homework?
I'll leave the meeting now.
Okay,
Me too.
thanks for coming.
Thank
Thanks for coming.
you.
Thanks,
Thank
Brennan.
you.
Thank you very much.
All right. Thank you.
Thank you.
And
Bye bye.
bye.